In this video, I will be showing you how to solve exercise 1117, which reads a 9-meter uniform beam is hinged to a vertical wall and held horizontally by a 5-meter cable attached to the wall 4 meters above the hinge, as shown in the figure below. The metal of this cable has a strength of 1.2 kilonewtons, which means that it will break if the tension in it exceeds the amount. So part A, well, first of all, this is the diagram. And part A reads, what is the heaviest beam that the cable can support with the given configuration? So we're going to come down here. So first thing that we need to find is the angle. And we were able to find that by using sine inverse and taking the sine inverse of 4.0 meters divided by 5.0 meters, which is the length of the cable as well as the height in the diagram here. And then once we do that, we can use the rotational equilibrium equation, which you see right here. And in order to, we are currently solving for the weight, we're currently solving for the max weight. So we rearrange the equation so that it ends up on the left side of everything alone, which gets us the weight, the max weight equals the tension max sine theta times 3 meters divided by 4.5 meters. And then we plug in the variables. So 1.2 times 10 to the power 3 newtons, which is the 1.2 kilonewtons we had earlier, times the sine 53.1 times that 3 meters divided by 4.5 meters, which equals 640 newtons, which is the max weight, but is asking for kilograms. So we find the mass by dividing the 640 newtons by 9.8, which gets us 65.3 kilograms, which is the max, the heaviest the beam can be for the cable to support it. And then we move on to part E. It says find the horizontal component of the force the hinge exerts on the beam. Suppose the positive direction of the horizontal axis is to the right. So we come down here. Right here, we use the translational equilibrium equation for the x component. So right there it reads sigma f of x fx equals fxh minus tension max cosine theta equals 0. So since we're solving for f of xh, we rearrange the equation to where it reads fxh equals tension max cosine theta, and then we input those variables, which is the 1.10 to the 3 power cosine 53.1, which gets us the horizontal component of the force, not the the horizontal component of the force, which equates to be 720 newtons. And then part C reads, find the vertical component of the hinge of the force the hinge exerts on the beam. Suppose that the positive direction of the vertical axis is upward. So we go down to here, and once again we use the translational equilibrium equation, which you see right here. And this time it's going to read sigma f of fy equals t sine theta minus w, which is the weight, minus force yh, which equals 0. So we're at equilibrium. Since we have to be able to solve for the force, the vertical component of the force of the hinge, we rearrange that so that f of yh is to the left all alone, which is going to read equal t max sine theta minus weight max. And then we input those variables, which you see right here, 1.10 to the power of 3 sine 53.1 minus 640 newtons, which gets us F of YH equals negative 320 newtons, and it's negative because the positive vertical axis, the positive direction of the vertical axis is upward, and this force is going downwards. And that is exercise 11.17.